On the left, these are all of the most common conversions that you kind of want to have handy. And on the right, I start you off with the Q equals MCAT equation. So if you go back to, thermodynamics class, this is the mass heat flow equation. And from this equation, you can derive all of these simplified HVAC specific using this equation at the top and then all of these conversions on the left. You can derive this 1.08 and this 4840 and this 4.5 and this 500 even. So the sensible heat equation for air, CFM times 1.08 times delta T, is kind of a quick way to say I have this much airflow, and this is the temperature difference between the discharge air and my set point. How much sensible load am I handling here? So the sensible heat equation for air, this is for sensible load only, because we're using dry bulb delta T. And this 1.08 has a lot of assumptions baked in, like it's sea level and our air density is like, 70 degrees. It's not extreme. So those caveats I just gave you for the sensible air heat equation, they apply to the latent equation too. Right? This is for latent load only. We're using our humidity ratio in this one. And this 4840 also assumes just standard sea level conditions. And then the total, remember sensible plus latent equals total. This is the total where instead of dry bulb temp or humidity ratio, you're actually using the overall enthalpy and this 4.5 to figure out what your total is.